could a compound from the cannabis plant actually be a secret weapon against one of the deadliest medical emergencies on the planet? It sounds like science fiction, right? Well, today we're going to dig into a huge scientific review to see what the evidence really says about using medical cannabinoids to fight the damage from a stroke. Let's separate the hype from the real hope. To really get why this research is so important, you've got to start with this number, 93.8 million. That's how many people were living with the effects of a stroke back in 2021. It is a massive global problem, a leading cause of both death and long-term disability that puts an unbelievable strain on families and healthcare systems everywhere. So the most common kind of stroke, we're talking about 2/3 of all cases, is an ischemic stroke. The easiest way to think about it is like a sudden catastrophic plumbing problem in your brain. A clot forms and completely blocks a vital blood vessel. That cuts off oxygen, it cuts off nutrients, and it starts starving brain cells, kicking off this devastating cascade of damage that can last a lifetime. When that happens, when a brain is under attack like this, doctors are in an absolute race against the clock. But the truth is, the tools they have to fight back are pretty limited. And that's exactly why the hunt for new, better treatments is so incredibly urgent. You see, our best weapon right now is a clot-busting drug called TPA. It's great, but here's the catch. It has to be given within a tiny window of just a few hours. A lot of people just don't make it to the hospital in time. Other drugs that are meant to protect the brain have had, well, mixed results at best. And the outcome? It's heartbreakingly high rates of disability and a global cost that's over 890 times billion dollars every single year. So this desperate need for something new has pushed scientists to look in some pretty unexpected places, which brings us to this very unlikely hero, medical cannabinoids. It's really interesting. As laws and attitudes about cannabis have shifted all over the world, there's been an absolute explosion of scientific research into it. And this explainer today, it's all based on a massive review that took all the preclinical research done on this exact topic over the last 25 years and analyzed it together. Now, we need to be really clear about something. When scientists say medical cannabinoids, or MCs, they're not just talking about the plant you might think of. They are studying very specific isolated compounds. Some are natural, like CBD and THC, and some are even synthetic, to figure out exactly what they do in the body and how they might be used to treat a disease. Okay, so what did this huge deep dive into 26 different lab studies actually uncover? Now, it is so important to remember this. All of this data comes from animal models of stroke, not from people. But what they found, it's pretty fascinating. The number one finding across 22 separate experiments was just incredibly clear and consistent. The animal models that were treated with medical cannabinoids had a major reduction in what's called infarct volume, which is basically the scientific way of saying the area of dead brain tissue caused by the stroke. Put simply, their brains had much less physical damage. But it wasn't just about preventing physical damage. I mean, what really matters is function, right? And the animals that got these compounds had way better outcomes. On tests that measured their neurological function after the stroke, things like their coordination and motor skills, they scored significantly higher. So not only was there less damage, they actually recovered better. And the good news just kept coming. The analysis found a whole bunch of other positive effects. It looks like these compounds helped improve blood flow, they reduced dangerous swelling in the brain, they calmed down the body's inflammatory response, fought off damaging oxidative stress, and even seemed to prevent cells from dying off. So the big question is, how? How is all of this happening? What's the science here? Well, it seems like these compounds aren't just a one-trick pony. They launch like a full-on, multi-pronged defense for the brain. The researchers basically summed it up like this. These compounds are hitting multiple targets, all at once. And that's what gets scientists so excited. A stroke isn't just one problem, it's a whole cascade of bad things happening one after another. So while a drug like TPA does one job, it busts the clot, these compounds seem to fight the chaos that comes after. They seem to stop something called excitotoxicity, which is this horrible chain reaction where dying brain cells release chemicals that poison their neighbors. These compounds look like they might just shut that whole destructive process down. And hey, don't just take my word for it. This is the conclusion straight from the authors of the study. They state that in these lab models, MCs offer a comprehensive, multi-target form of neuroprotection. That's the key right there, the potential to fight the whole fire, not just the spark that started it. But, and you knew there was a but coming, and it is a very, very big one. We have to hit the brakes here. As amazing as these lab results sound, There is a giant canyon between a study on a lab animal and a proven treatment for a person in a hospital bed. And this part is just so critical to understand. Lab research, by design, uses young, healthy animals in perfectly controlled settings. Real-life stroke patients are often older, they might have high blood pressure, diabetes, or a dozen other health issues that these lab models just don't have. Human bodies are just infinitely more complex. The study's authors are really upfront about these roadblocks. As of right now, there are 0 high-quality clinical trials in humans for treating an acute stroke this way. We have no idea what a safe dose would be, we don't know what an effective dose would be, and of course, you have to think about potential side effects, like psychoactive effects or addiction, especially with compounds like THC. So, what's the big takeaway here? What should you walk away with? It's this. This research is an absolutely vital first step. It gives us a solid scientific reason to keep investigating this. But it is not proof of a working treatment for people. This is just what the very, very beginning of that long road of medical discovery looks like. And that leaves us right back where we started, with that central question: do these incredibly promising lab results point to a real new frontier in treating stroke, or is it just hype? The only way we'll ever know is through years of careful, rigorous, large-scale human trials. For now, it's a tantalizing glimmer of hope on what is sure to be a very long scientific journey.